Before we proceed on our discussion, let me present to you our objectives. At the end of this video, you should be able to recognize the characteristics of a graph of a polynomial function, solve the x and y-intercept of a polynomial function, identify the end behavior of the graph using leading coefficient test, identify the steps in graphing polynomial function, sketch the graph of the polynomial function. On the previous lesson, we talked about polynomial function. For this video, we're going to discover how do we graph a polynomial function. But before that, let's have a review about the Cartesian coordinate system. Cartesian coordinate system composed of two intersecting lines. The horizontal line is what we call the x-axis, and the vertical line is our y-axis. Also, we have four quadrants. For the first quadrant, the values is positive for x and positive values for y. For the quadrant 2, we have negative values of x and positive values of y. For quadrant 3, we have negative values of x and negative values of y. For quadrant 4, we have positive values of x and negative values of y. Suppose that we're going to plot the points 3, negative 4. So we have 3x and negative 4y. So the point is on quadrant 4. Next is negative 2, 2. So we have negative 2 for x and positive 2 for y. So the point is on quadrant 2. Also, we have 0, negative 3. So 0 values for x and negative 3 for y. So the point lies on the y-axis. Next is 4, 0. 4 for the value of x and 0 for the value of y. So the point lies on the x-axis. Let us now recognize the characteristics of graphs of a polynomial function. The polynomial function is a smooth curve, which means that the polynomial functions of degree 2 or more have graphs that do not have sharp corners. Which of the two figures illustrate a smooth curve? You are right. The first figure illustrates a polynomial function, while the second figure is not, since it has sharp corners. Another characteristic of a polynomial function is it is continuous, which means that the polynomial function displays a graph that have no breaks. Which of the figure illustrate a continuous function? You are right. The first figure illustrates a continuous since it does not have any breaks. And the second figure is not a graph of a polynomial function since it contains breaks. After recognizing the characteristics of a graph of a polynomial function, we can now proceed on the 5 easy steps in graphing a polynomial function. The first step is to determine graph and behavior. Second step is to find the x-intercepts or zeros of the function. The third step is to find the y-intercept of the function. For the fourth step, we need to find the number of maximum turning points. And for the last step, we can now draw the graph of a polynomial function. For this video, we're going to graph the polynomial function f of x is equal to negative x cubed minus 4x squared minus 3x, and f of x is equal to quantity x minus 2, quantity x minus 5, quantity x plus 2, quantity squared. To start, we're going to determine the end behavior of the graph using the leading coefficient test. The graph can be in the form of PE, PO, NE, or NO, wherein PE stands for positive even, PO is for positive odd, NE for negative even, and NO for negative odd. So if the leading coefficient is positive and the degree is even, the behavior of the graph is rising on the left and on the right hand. If the leading coefficient is positive and the degree is odd, it falls on the left and it rises on the right hand. If the leading coefficient is negative and the degree is even, it falls on the left and on the right hand. If the leading coefficient is negative and the degree is odd, it rises on the left hand and it falls on the right hand. Since our polynomial function is f of x is equal to negative x cubed minus 4x squared minus 3x, we can easily determine our leading term, that is negative x cubed, wherein the leading coefficient is negative and the degree is 3, which is an odd number. Therefore, the graph of this polynomial function looks like NO, wherein the behavior of the graph is rising on the left hand and falling on the right hand. Next step is to identify the x-intercepts or zeros of the function. The polynomial function can be written in the form of y is equal to negative x cubed minus 4x squared minus 3x. To transform the polynomial function into a factored form, we're going to factor negative x, so we have negative x cubed divided by negative x is equal to x squared. Negative 4x squared divided by negative x is equal to 4x. Negative 3x divided by negative x is equal to 3. We can still factor the quadratic equation by thinking of two numbers that when we multiply, the product is 3, and when we add, the sum is 4. The two numbers are 3 and 1. So, the factored form is y is equal to negative x, quantity x plus 3, quantity x plus 1. Since we already have the factored form, we can now set y is equal to 0. After setting y is equal to 0, we can now equate each factor to 0. Then we will find the value of x. So we have x is equal to 0, x is equal to negative 3, and x is equal to negative 1. Therefore, the x-intercepts or the zeros are 0, negative 1, and negative 3. After getting the values of x-intercepts, we can conclude that the graph will pass through 0, 0, negative 1, 0, negative 3, 0. Step number 3. After identifying the values of the x-intercepts, it's now our turn to find the value of the y-intercept. To do that, we're going to set x is equal to 0. So we have y is equal to negative 0 cubed minus 4 times 0 squared minus 3 times 0. Then we're going to simplify. So we have 0 minus 0 minus 0, or y is equal to 0. The y-intercept is 0, which means that the graph will pass through point 0, 0. Step number 4. Find the maximum number of turning points. The maximum number of turning points can be computed in the form of n minus 1, where n is the degree of the polynomial. In the given polynomial function, our degree is 3. So, 3 minus 1 is equal to 2, which means that the maximum number of turning points is 2. For the last step, we can now draw the graph of a polynomial function using the given information. The end behavior of the graph is rising on the right hand and falling on the left hand. The x-intercepts are 0, negative 1, negative 3, which means that the graph will pass through point 0, 0, negative 1, 0, negative 3, 0. The y-intercept is 0, which means that the graph will pass through point 0, 0. The maximum number of turning points is 2. After identifying the end behavior, which is rising on the right hand and falling on the left hand, we can now plot the points in the Cartesian plane. we have 0.00, point negative 10, and point negative 30. Then we can connect them using curves. As you can see, the graph of the polynomial function started on the second quadrant, passing through the x-axis, going to third quadrant, passing to the x-axis, going to second quadrant, passing to the origin, going to fourth quadrant. Let's have another example. We're going to graph the polynomial function f of x is equal to quantity x minus 2, quantity x minus 5, quantity x plus 2, quantity squared. But before that, we're going to find the end behavior of the graph using the leading coefficient test. First, we're going to factor the polynomial function and multiplying all the variables to get the leading term. X times x times x times x will give us x raised to 4. Therefore, we can see that the leading coefficient is positive and the degree is even. Therefore, the graph of a polynomial function looks like PE, or positive even, which makes the end behavior rising on both left hand and right hand. Step number 2. We're going to identify the x-intercepts or zeros of the function. The polynomial function can be written in the form of y is equal to quantity x minus 2, quantity x minus 5, quantity x plus 2, quantity squared. Then we're going to set y is equal to 0 and equate each factor to 0. So we have x minus 2 is equal to 0, x minus 5 is equal to 0, and x plus 2 is equal to 0. Then we're going to find the value of x. So we have x is equal to 2, x is equal to 5, and x is equal to negative 2. Multiplicity of 2, since we have an exponent of 2. Therefore, the x-intercepts or the zeros are 2, 5, and negative 2 multiplicity of 2, which means that the graph will touch the points 2, 0, 5, 0, and negative 2, 0. Next step is to identify the y-intercept. To do that, we will set x is equal to 0. After substituting the value of x by 0, we can now simplify. So we have negative 2, 0 minus 5 is negative 5, 0 plus 2 is 2 squared. Then we have 2 squared is equal to 4. Multiplying negative 2 times negative 5 times 4 will give us 40, which means that the y-intercept is 40, therefore the graph will touch point 0, 40. Step number 4 is to find the maximum number of turning points. So the maximum number of turning points can be computed in the form of n minus 1, where n is the degree of the polynomial. To find the degree, we're going to find first the leading term. Multiplying all the variables, we have x times x squared will give us x raised to 4, which means that the degree is 4. So 4 minus 1 is equal to 3. That means that the maximum number of turning points is 3. We're going to talk about zeros and multiplicity. The graph of a polynomial function will touch the x-axis at zeros with even multiplicities, while the graph will cross the x-axis at zeros with odd multiplicity. The first figure illustrates a function with zero multiplicity, where it only crosses the x-axis. For the figure number 2, it illustrates a multiplicity of 2, wherein the graph will touch and bounce off to the x-axis. And for the illustration number 3, it is the multiplicity of 3, wherein the graph will still cross through the x-axis, but the graph will appear flatter as it approaches and leaves the x-axis. For the last step, we can now draw the graph of a polynomial function. The end behavior of the graph is rising on both right hand and left hand. The x-intercepts are 2, 5, and -2 multiplicity of 2, which means that the graph will touch the points 2, 0, 5, 0, and -2, 0. The y-intercept is 40, which means that the graph will touch the point 0, 40, and the maximum turning points is 3. Since we already know that the end behavior is rising on the right hand and on the left hand, we can now plot the given points. 2, 0, 5, 0, -2, 0 twice, and for the y-intercept, 0, 40. We can now connect the dots using curves. As you can see, the graph of the polynomial function started on the second quadrant, touching the x-axis, bouncing off, and touching to the horizontal axis, going through the x-axis to the fourth quadrant, then touching the x-axis going to the first quadrant. We have 3 turning points, 1, 2, and 3. This is now the graph of the polynomial function f of x is equal to quantity x minus 2, quantity x minus 5, quantity x plus 2, quantity squared.